Good morning. Hi, welcome everyone. Today we're in a single-family house that's being built using the timber frame technology. Right now, the heat recovery ventilation system is being installed. And you might think that every building is different. Every installation is done differently. No, the rules are exactly the same. So the entire ventilation system, that is, the ducts, the heat recovery unit, the ventilation unit, must be installed in the warm zone, meaning in the heated, insulated area. And the differences that exist compared to buildings made with other technologies, like masonry or poured concrete, versus a building using the frame technology, concern the installation and placement of all the ducts and the entire air distribution system. Here, in this particular room, which is a bedroom, the investor requested that the beams installed above remain visible, so all the insulation that is being installed, both in the roof section and in the roof slopes, will be added between these beams. It is also being installed above. I'll try to get in and show you. But I should have put on a helmet. The insulation here will fill the space between the beams. That's why, to make sure the entire installation is under the insulation, we've moved out the boxes, and soon the cables will also be installed in this section, right under the insulation. Here, a suspended ceiling structure will be installed next, and all of this will be covered, but the insulation will be above the boxes, above our ventilation and heat recovery installation. So that's a small difference, because normally, if the investor hadn't asked for the beams to be visible, we could have installed the boxes here, in the space between the beams, filled the space between the beams with insulation, or even added more insulation above the beams. And then our installation, our boxes, our cables would be in this warm, heated, insulated space. Let's maybe move to the other side of the building, to the next bedroom. Here it's the same situation. The beams are also supposed to be visible, so that's why the entire installation, the plenum boxes, went up under the roof structure, but also under the part where the insulation will be distributed and laid. As for the bathroom, the plenum box that will be installed in this room will be mounted on the OSB board from above, from the other side, so it will also be under the insulation that will run along the roof slopes. So it will be in the warm space, that is, in the heated, insulated zone. Here, we actually have a situation where we have a 4 by 75 to 160 plenum box. So for this room, for the bathroom, this will be the appropriate box. Okay, so those are the main principles, the main rules, right? Because you could say that structurally there might be some discrepancies, there might be some differences, but when it comes to installing the whole ventilation system, or actually the air distribution system, that is, the pipes and ducts, we install it in the warm zone, meaning in the heated and insulated area. In this case, with this kind of solution, the entire ventilation system operates most efficiently and correctly. In a moment, we'll go downstairs to the floor below and discuss the next part of the installation. We're on the ground floor now, in the same building, specifically in a timber frame construction building. We have several supply and exhaust points. Right now, we're in the area where the kitchen will be located, connected to an open living room. And when it comes to installation, we need to mount everything under the beams so that we can run the ducts between the plenum box and the distribution box mounted under the ceiling. But these are not just important technical issues. It's also worth taking them into account. For example, here in this building, we also considered the lighting points that are installed on the ceiling, so that our exhaust or supply boxes are mounted in the same line, on the same axis, to make everything look nice. So we can combine the technical function with the aesthetic aspect as well. Installations can also look nice, right? So let's try to do it that way. As for the number of points, we have 2 points located in this kitchen area. 2 points will also be located in the living room area. One here, the other one here as well, synchronized or made together with the lamp. And additionally, we still have the remaining rooms, such as here a study is planned. So there will also be a supply point, the vestibule room, which will have an exhaust point, and the bathroom, where an exhaust point will be installed. That's regarding this part of the ground floor in this building. Meanwhile, the heat recovery unit will be installed in the garage below, and we can go there in a moment to discuss the location of the unit. While we're at it, with the situation we have here, I'll explain the issue regarding the plenum boxes offered by the company Peflex. We have plastic boxes with a connection stub diameter for the diffuser of 125 millimeters. However, when it comes to other diameters, such as 100, 125, or 160, we can use metal boxes like this one here, right? Here we have a connection for 4 75mm plastic ducts and an outlet, an approach for a diffuser with a diameter of 160. How does that translate? To achieve the same air output, the same airflow, we can use 2 of these boxes or 1 metal box like this. In terms of air distribution, it's better to install 2 boxes so that the air spreads more evenly, for example, throughout the bedroom, the living room, or other rooms. However, due to the limited space on the ceiling, we can use a box like this one here, with a 160mm air diffuser, to extract and direct the right amount of air from here. So, I invite you to visit the Scenic24 website for more information about the boxes offered by Peflex. We are in the garage, and on this wall, the heat recovery unit will be located. This is the north wall in terms of geographic directions, so somewhere around here on this wall, the intake grill is planned. Meanwhile, at a distance of at least 1.5 meters, the exhaust grill will be installed. This actually works out nicely, because the V-type heat recovery unit has the intake on the left side here, and the exhaust on the right side here, so it will be a very simple setup to connect the unit directly to these wall penetration points, meaning the intake and exhaust. So that's more or less how the planning looks, right? The implementation of the entire unit, meaning the whole ventilation and heat recovery system in this building. So you could say that the technology is completely different from masonry construction, at least when it comes to the upper part. But more and more often, buildings are being constructed using the frame technology, even in mountainous areas, right? Where are we today? We'll show you from the outside what this building looks like. Why? Because informed clients pay attention to the building's energy consumption. And that translates into a situation where we really have to insulate the building properly so that it loses as little heat as possible through the building partitions. Okay, this is what the building looks like from the outside. The lower garage section is built with masonry technology, while the upper residential part uses a frame construction, a timber frame house technology with insulation called Styco. Supposedly, it's good insulation. I don't really have anything more to add here, so that's how it looks. Like I said, we have this masonry part, where the recuperator will be located downstairs in the garage, and then through the vertical shafts, the air will be distributed throughout the entire building. The building is actually situated in such a way that the living area, like the living room or the upstairs room, is directly facing south, which is important when it comes to the principles of a passive building, a passive house, right? So that large glazing, which can be built on the southern side, can be used in the winter to harness the sun's energy for heating or supplementing the heating of the building. But, and this is important, but it's also worth considering what to do during the summer. So if we have such large glazing on the southern side, it's worth installing external blinds, shutters, or a combination of the two, an external shutter blind, so that in the summer we can limit sunlight and reduce heat gain in the building. Unless, of course, we decide to install an air conditioning system that will remove the heat from the building. Although it's also worth considering air conditioning, because just as heating and ventilation are responsible for thermal comfort in the home during winter, in the summer, it's ventilation and air conditioning that ensure proper thermal comfort. The main task of air conditioning is, above all, it's to lower the temperature, but also to reduce humidity. So if we lower the humidity in such a building, our bodies, our skin, will also perceive the heat in the building differently. And in that case, we experience better thermal comfort throughout the entire house. So it's worth installing 3 systems in buildings, even in energy-efficient ones: heating, heat recovery ventilation, that is, recuperation, and air conditioning to ensure comfort during the summer. Thank you.